God bless you, class. Good morning. How are you all? Class, today we are going to study about atoms. Chapter number 7, first lesson. Atoms are defined as the smallest particle of an element. Not only the element, atom is the smallest particle of matter, in fact. And atoms cannot be seen with an ordinary microscope because they are very, very, very small particles. And you know what? A single atom measures about 0.1 nanometer. 0.1 nanometer means 10 raised to the power minus 9 meter. And one more thing, that atoms of an element are same. This is what I told you very earlier. As atoms are the smallest particle, and this particle is reacting. This particle is not stationary, it's all time in energy. And one more thing about it, that atoms of an element are same, they are identical, and we have to consider their size. We are talking about atoms all the time, but we are talking about a particle which cannot be seen through a naked eye or even by an ordinary microscope. Its size around 0.1 nanometer. Like silver. Silver is an element and it is used to make ornaments and jewelries. And when we see the structure of this pendant, we will get to know that all atoms in this pendant are same because they belong to the same element. Like here, the ozone, all atoms are same. Hydrogen, atoms are same. Oxygen, atoms are same. Chlorine, atoms are same. And sulfur, all sulfur atoms are making up the molecule. So here we see more about them. You know, the atomic model was researched by different scientists with their proposals. And the first model of atom was presented by John Dalton in 1803. And he defined atom as the very small hard sphere that is indivisible. Indivisible means the particle which cannot be divided, the particle which behaves as a unit, the particle which is the functional unit of matter. So John Dalton proposed that the atom is a sphere which cannot be cut into halves. The next model came forward by J.J. Thomson in 1897, and he proposed the structure of the atom as it is a continuous mass of positive charge containing negative charge electrons on it. His model was also called as plum pudding model, as if we have plums embedded on the pudding like this. And you know, the plums pudding model tells us that the negatively charged particles are embedded or are present or spreading all over the size of the atom. The next model was forward by Rutherford. Rutherford proposed his model in 1911. And he said that the atom has a nucleus surrounded by electrons. Now, when we see at the plum pudding model, the negative charge is equally spreading all over the sphere of the atom. But here, he is defining us that the positive charge is gathered or concentrated in the central part of the atom, which he called as nucleus. So the positive charge is concentrated, gathered, or present in the smallest space of the atom, which is called as nucleus. And the electrons carry negative charge, which are dispersed and distributed all over the atom, all over the sphere of the atom. The next model was by Niels Bohr in 1930. Niels Bohr made his proposal or made his model of atom as the atom has a nucleus and electrons move in fixed orbits around the nucleus. So here we see the Rutherford models. Rutherford did not speak about the movement of negative charge or electrons, but here the Bohr's model is telling us that the positive charge is present in the nucleus and the negative charge is revolving around it. So this is why the movement of electrons is discussed in circular orbits around the nucleus. The next model is the modern model of atom, which tells us that electrons are found in high probability regions outside the nucleus. Last four models are telling us that the electrons in somewhere outside in the outer sphere space, like the positive charge is present in the center of the atom and the negative charge electrons particles are moving outside the nucleus. And now we are learning a new term, that high probability. Probability means the possibility of finding. So the possibility of finding these electrons are outside the nucleus. So it's a region where electrons can be traced, can be found. So we cannot assign a single position to these fastly moving electrons. Why I said fastly moving? Because electrons are much more energetic and they keep on moving around the positive sign, around the nucleus. So as their speed is too high, we cannot trace them where they are present at what time. So that's why we are using a typical term here, probability. So electrons are found in high probability regions around the nucleus. Now when we see today's model of atom, which is a quantum model. Quantum model of the atom is based on experimental data and evidence. Like we have performed experiments. The nucleus is the central part of the atom where positively charged protons and neutral particles, neutrons, are present. Like we are okay with this point that positive charge and neutrons are present in the central part of the atom, which we call as nucleus. But the negatively charged electrons move around the positively charged nucleus, and most likely to be found the regions are called as orbitals. So high probability regions around the nucleus are called as now orbitals. So orbitals are the places in which the electrons are more likely to be found all the time. Now today's class is, what do you mean by a scientific model? Like we have seen so many models of the atoms proposed by different scientists at different times. Why a single atom is why the single proposal or theory or law is accepted and why it is rejected? This is the question which needs your interest. Like you can find this answer from your textbook or from the internet and get to know that why a model is accepted and why a model is rejected. So you have to go through the topic very well from the textbook and then write your answer to this question, that what do you mean by a scientific model? Okay class, thank you. Take care. God bless you.